So we've talked about average velocity, we've talked about instantaneous velocity. The next question to ask is, what do these actually mean graphically? So let's look at graphs and talk about average velocity and instantaneous velocity. So let's think about a graph. If I graph my position function, so let's say this is my position, something like this. So this is my S of t, where I'm measuring t along the x-axis. If I pick two values here, so let's say this is my t1 and up here is my t2, and I connect them with a line. So let me get a different color here. If I connect these two with a line, can I find any sort of correlation between this line and the average velocity? So let's think about this. What's the slope of the green line? So the green line that I just drew, what's the slope of that line? Well, the slope of any line is the change in your y's over the change in your x's. Well, I know the change in my x's. That's just t2 minus t1. What about the change in my y's? Well, it's going to be the function value at t2 subtracting the function value at t1. So that is s of t1, or t2 minus s of t1. Is that something that we've seen before? Yes, it is. That is, in fact, the average velocity. This line that I just drew has a special name. It's called a secant line. So a secant line is a line connecting 2 points on a graph, or on a curve. So I picked 2 points, I found the slope of the secant line, and we said that is average velocity. So graphically, what is average velocity? It's the slope of the secant line between any 2 points. So graphically, the average velocity is the slope of the secant line between 2 points. Which makes sense. The average velocity was given by the change in my position over the change in time, which is precisely the slope between any 2 points. And if you connect those 2 points, it's the secant line, so it's the slope of the secant line. So that's average velocity. That's how we can imagine that graphically. But what about instantaneous velocity? Again, let me draw a position here. So let's say that my position is given by s of t, where this is my s of t. And I want to talk about instantaneous velocity at a point. Well, instantaneous velocity at a point, how we were estimating it was to pick a point close by and find the average velocity. So that was the slope of that line. Then we said I could do better. I could pick a point that's even closer and find the average velocity between those two. But I could do even better than that. I could pick a point that was even closer on my curve and find the average velocity between those two, which is the slope of all of these secant lines. Now, if we look at the limit of these, or what are these going to? It's going to a tangent line. What is a tangent line? A tangent line is a line that intersects a curve at one point locally. So the reason I say locally is that we're only concerned about looking relatively nearby our point. These lines can intersect the curve elsewhere, but relatively speaking, a tangent line only intersects the curve in one point. So if I draw this graph again, just so we can really see what's happening here. So here was my point at T1. How you find the tangent line, I think the easiest way to do this is actually take kind of a note card here. The tangent line is the line that's touching just at one point. So you can see if I move this along and I come here, that's going to be my tangent line. So if I move along, the tangent line to that point would be right there. So let's see, to that point, my tangent line would be here. What's the correlation between the slope of the tangent line and the instantaneous velocity? Well, since all of my secant lines were going towards my tangent, it tells us that the slope of this line is our instantaneous velocity. So the instantaneous velocity is the slope of the tangent line. You can also think about the tangent line as if I zoom in close enough. So if I were to change my viewing window and I kept getting smaller and smaller, eventually this curve's going to look like a line. That's your tangent line. So if you zoom in close enough, it looks like a line. That's your tangent line. It touches at just one point locally. I mean, this curve's going to touch somewhere else over here, but just in this region, it's just touching once. So the tangent line is the line that just kind of touches the curve, and it's giving you the slope, and that's the instantaneous velocity. So average velocity, that's the slope of a secant line if you connect the 2 points. Instantaneous velocity is the slope of the tangent line at a point. So that's how you can graphically think of these.